All right, the duration of a professor's class is a continuous uniform distribution between 4.92 minutes. Okay. It has a uniform distribution between 49.2 minutes and 55.5 minutes. If one class is randomly selected, and the probability that the duration of that class is longer than a certain number of minutes, the duration of the class is longer than a certain number of minutes, they're saying the probability that duration is longer than a certain number is 0.365 minutes, or 3.56. Sorry, it's not minutes. That is the probability. Is 0.365. Then find the duration of the randomly selected class if P of X is greater than C. So what they're telling you is if our random variable is greater than some number C, the probability will equal 0.365. And they want us to find that C such that the probability will equal 0.365. So this is what it looks like. This problem is very similar to a lot of the other problems in this section. I mean, in the beginning, at least, it's the setup in these first steps are the same. So we're just gonna do the problem exactly as we did before. So the uniform distribution is between 49 and 55 minutes. So 49.2 is right here, and 55.5 is over here. And it has a uniform distribution. Oh, that's a terrible straight line. That wasn't much better, but I tried. Okay. Okay. Well, that wouldn't really be the case because it would be a lot shorter, of course, if it was actually drawn to scale, but it's not really drawn to scale. Okay. So the first thing that we have to do in these problems is figure out the base of the entire uniform distribution. So that's from 0.92 all the way to 0.55. So that distance is, let's do the on the calculator here. It's 55.5 minus 49.2. See if I did that correctly. Okay, enter. Okay, that's 6.3. So this distance across the bottom of this uniform distribution is 6.3. And then over here, the distance here, the height then is automatically 1 over that value. So 1 over 6.3. That's not pretty because there's a decimal in this fraction, but I'm just going to leave it as it is for right now. I won't worry about it. Okay. Now, they say there is some value C, and it's between 49.2 and 55.5, such that the probability of this being greater than the lecture lasting longer than C is 0.365. So I'm going to say, let's just say this is C right here. Then the area, since they said that the variable is great, the probability of the variable being greater than C, that means the area of this rectangle above it. So above C, because the values greater than C are to the right of C. So this green area would be, and I know it is, 0.365. Okay, the area of that, the area of being our value of the probability of a random lecture being between C and 55.5 is 0.365. So we have a choice here. We could do this problem using this 0.365. It's slightly not so nice because we we could, it doesn't matter. We also could look at the situation too and consider it too that that this other area, so there's like this area of this red rectangle right here. All of the rest of the area under the curve, under this uniform distribution, that would be 1 minus 0.365. So this is 1 minus 0.365, which would be, right, because all the area under a probability distribution should be one whole. So that's why 1 minus 0.365, we could say that area is 0.635. So that just gives us a few different options, just because we want to use a rectangle and write the same formula that we've written before. And it might be, and maybe I might go with this. The probability and that X, so I could use the red rectangle and do this problem with the red rectangle. The way I could do that is I could say, okay, well, this formula says X is greater than C. But I could say if X, the probability that X will be less than C, I have it written right here, that is 0.635. So I could write the area of this rectangle and set it equal to this, or I could use this second green rectangle. I kind of like this first red one because then C stays positive as we'll see, we're going to take C minus the 49.2 to find the area of that, to find a base there. And that means our C is positive, and it just makes the things a little bit easier and prettier in our calculation. So I'm going to use this red rectangle because we knew the probability of it being greater than C was 0.365, then that told me that it being less than C would be 0.635. Well, less than C would be this red rectangle. So to find the area, now I have to find another way to write this expression, probability of X less than C. And that's recognizing that that's equal to the area of that red rectangle. Correct. Okay, so the area formula for a rectangle says base times height. Well, the base of this red rectangle is right here. So to figure out base, I subtract the endpoints, the larger endpoint minus the smaller endpoint. And so C is supposed to be a number bigger than 49.2. Otherwise, it's not even a possible lecture time, you know. So we put base is C minus 49.2. And the height we already said was 1 over 6.3. And we said that we already know this probability. The probability of being less than C, that probability is 0.635. So now we have an equation. We have one unknown, the C, and we have everything else here known. So to get rid of, I just want the C minus 42.9.2. So I need to get rid of this 1 over 6.3. So I can multiply on both sides by the reciprocal of that, 63 over 6.3 over 1. So I'm going to rewrite this equation. Put 60. And then I get I just multiply, because 6.3 over 1 just means 6.3, and it's 60.3 divided by 1, it's just 6.3. So I multiply the 0.635 times by 6.3, and I get this 4.0005. And then I just add 49.2 to both sides. Now I'd have to make sure to line up my decimals really well, but now I just add 49.2. And I get this 53.2005. I think that was the number that we got. 53.2005. Yeah. Okay, and that is our C. That is the number that such that if you're greater than the probability of you being the lecture going longer than 53.2005 minutes is 0.365. And the probability of it being less than 53.2005 minutes is 0.635. So there we go. That's our answer. Let's just double check it. And they rounded it to 1 decimal place, so they got 53.2. But that's, there we go. That is right. That is what you want. All right. All right. Thanks for listening. Bye.